I was thinking what would happen if we used steel insulated wire as the core. So we're connecting the magnetic flux path with the steel core, but we're also harvesting the induction through the core. So what would happen? So I'm putting in 21 volts at 0.25 amps, 1/4 of an amp, 250 milliamps. Okay, I'm looking at voltage coming out of the core material and amperage, alternating current amperage, 421 milliamps coming out of the core material. Now the voltage is barely anything because it's extremely low resistance. This is a 1/4 inch, maybe bigger wire, just making a couple turns. So it's producing good amperage as opposed to input. Output voltage isn't much. But the weird thing is, well, the interesting part is, if you pull amperage, now I'm going to disconnect the circuit on the core. As you see, the amperage is going down to 0. It's dwindling away. And look, the power supply is the same. So connect it again, pull our 400 milliamps, and the input power is the same. Now watch the voltage on the induction coil. We only have 95 millivolts in this situation, but I think you could increase that by more turns of thinner wire. Now I'm going to unhook it. 127 millivolts. Now I'm going to short it. It goes up to 496 millivolts. The voltage goes down a little bit on this, but not much. And the input amperage stays the same. How could this be adapted to a better system? But basically the core material, use steel or iron to complete the flux path and for induction at the same time. Interesting.